So in this particular lab, basically our task was to design a FIFO as well, a convertible FIFO as well as the SRAM. So I'll just make you through with the PDF as well, like what was the PDF which was given to us. So basically lab aid consists of a convertible FIFO, that is SRAM memory. So basically we need to design a FIFO as well as SRAM in a single block. So basically what is the motive behind designing a FIFO is that suppose I have a Ethernet and it is giving a particular set of packets. Okay, so basically I will be using at that particular point of time I will be using that particular block as a FIFO, and whereas if I am not giving any kind of packets to that particular blocks, then it will be normally used as a SRAM, and normally the data will be written in a random locations instead of writing in a first in and first out basis. So this was the general diagram which was provided to us. So I will just walk you through what are the basic things that I have changed in my code. So basically whatever changes that were needed were done in the data memory itself. So I will just make you through the data memory code that I have written. Okay, so yeah, so here is the code. Data memory. Okay, so in the data memory, basically what I have done is, so basically I have written down 4 different stages, or we can say states. So in the first state, what I have done is it will do a normal operation, whereas it will be performing as a normal SRAM, where it will take the data and it will just process to the pipelining. Later on in the state 2, suppose we need to go to the state 2, then we have a signal named as set FIFO. So whenever this particular signal is high, that is set FIFO is equals to 1, then what we do is we basically use that particular block as a FIFO, which means that the packet, the payload data which will be given by the Ethernet will be directly written inside that particular FIFO, or we can say the memory block that we have designed. And later on, if we want to read the particular FIFO, like suppose after loading the payload data on the FIFO, and after processing whatever operations that we need to perform on that particular packets, and if we want to read the particular packets as well, then I have designed a particular state as well, where in that particular state basically we'll be reading the data of the FIFO which has been changed. So basically I will just walk you through what with the simulation that I have done. So in here you can see that at first, so basically here you can see this is the tail address that is incrementing. So basically it is nothing but the, as we know that there is a FIFO counter which will increment right after writing to a particular location. So this is nothing but we are writing to a successive locations. So basically 0 1 2 3 4 5 6 will be written in the FIFO. So you will see that when they were set FIFO, so I will just show you. So whenever, see here set FIFO is 0, which means that this particular memory will behave as a normal SRAM. So at that particular point of time you can see that the simulation results that we have. So the simulation result here you can see. So this was the normal operation which we were doing in a pipeline, where we were storing the data. So suppose for instance it was 0, then we were supposed to store 10 information 10 in it, and so on. So it was first performing as a SRAM. So now when the state is changed, that is the state FIFO is been 1. So state FIFO, just a minute. So here you can see that after a particular point of time we are making state FIFO as 1. Set FIFO, okay, set FIFO as 1, and later on once the state FIFO is 1, then you can see that we are writing information in the successive location, that is 0 1 2 3 4 5 6 and so on. So here you can see that at the end, once the data starts been writing in the each and every clock cycle, you can see at first clock cycle 1 will be written 2 3 4 5 6 7 8 and 9 and so on. So basically what we are doing is, for this particular example we have been using 15 location, that is 15 depth of a particular block. So it can be changed accordingly regarding our applications. So this was the basic simulation that we did, where a single block can be used as a FIFO as well as SRAM at the same time. So this was the motive of this particular lab. Now this particular code has been implemented in the FPGA as well. We are trying, there were some areas that we need to fix, but we are trying to solve that error as well. So for now we have completed with our simulation as well. Thank you.